Do you ever wish you had an easy solution to monitor all the power usage in your home in various circuits in a real accurate method? We're going to show you how. Let's check it out. So if you've seen in some of our other videos, we did some various dryer notifications that we kick off voice notifications and many other types of notifications just to tell you to say the washer and dryer is done. Well, we bring this one step forward and we want to monitor the entire home, and we also want to monitor various circuits in the home that may drive other automations, or just want to know how much power different devices are using. Not to mention, you can get some real cool graphs in Grafana that show all the timeline usage of all your power. So how do we do it? We're using a power monitoring board that's built by circuitsetup.us. Before we jump off into the board, I'm going to let you know that we will be using this with ESPHome, so it offers a very easy solution to get integrated into Home Assistant, since you can use that with an API or MQTT, etc., and there's no coding of Arduino sketches and everything. It's just going to be using ESPHome that many are familiar with. So they do have a 2-channel board and a 6-channel board, and the 6-channel board is also stackable, where you can add another 6-channel board to get 12 channels. Now, some folks, if you want to do in the US just their whole home, the 2-channel board would do great for you, since typically in the residential home in the US there's a split phase, or as some people do call it 2-phase, but it's technically a split phase, and you're only going to need the 2 CT clamps and you can monitor your entire home. Now, I've been using the 2-channel board in my home for many months with a custom Arduino sketch, but I recently did switch over to using ESPHome and it does work great. Now, before the recording of this video, I also changed over to the 6-channel board. That way I could monitor the 2 split phases coming in, as well as monitor 4 circuits as well. And one great one you could do is monitor your electric dryer for your notification. Instead of having to build a little board with the CT clamp on it, you could just use this and monitor it at the breaker panel. Now, some of you are probably thinking, hey Travis, well look, why don't you just build 2 of those and monitor your whole home with that same CT clamp you did for the dryer? Well, I can tell you one thing, and I'll just get to it straight. The chip on these boards is downright amazing. How you can hold a 1 amp or even half an amp load and measure it accurately with a 100 amp CT clamp and it holds it steady is quite simply amazing. It's definitely a professional power monitor chip that you definitely won't find in any other little smart plugs and anything like that. This just gets the job done. At the core of the board is the ATM90E32AS. It's a great chip. There's a lot of information on it, and we'll leave all the links to this if you want to read up on this chip. It's truly an awesome chip to use for power monitoring in your home. Of course, on the 2-channel board, they don't have where the ESP chip can plug directly into that board, but they do have an adapter style plate that can actually accommodate plugging in your ESP32 directly to it, or you just could do it yourself with a couple DuPont jumper wires from the ESP32 over to the 2-channel power monitoring board. But of course, on the 6-channel board, you can just plug in the ESP32 straight to the board and it does get power from the power adapter. And then alongside here in this picture is also the one that can be stacked on top of it to expand it to more channels. Now that we talked about the cool stuff, well, let's go ahead and talk about the not so cool stuff. You will be installing this in your breaker box. And I cannot stress this enough. The wiring in the breaker box will kill you immediately. You can't just go in and turn off the top breaker. For example, in this breaker box here, the top breaker, once you turn that off, those 3 wires coming in the top, you can see the blue one here, that's the neutral, and then the 2 split phases, those are still hot. The only way to remove power from those would be to actually pull the meter from the home. And typically you will need to call your electric company to do that. So the easiest way, if you want to put these clamps on and you're wanting to put them on the whole home power monitoring, where you're wanting to put them above your main breaker, I would definitely consult an electrician and have your electrician come out, pay them, suck it up, get it done, let them do it safely and put those clamps on for you. Now on your secondary circuits, if you do cut the main breaker at the top, you are cutting the power down to the bottom of the breaker box. But unless you're very comfortable installing stuff or changing breakers out in your breaker panel or rewiring stuff, I also would have the electrician at that time also install the clamps on the circuits you want. So you may want to, before they show up, to do that is map out some of your circuits by cutting some of the breakers off and figure out which ones you'd like to map. After they're installed, they don't have to be touched. It's a one-time thing. They can put them in and be done with it. But I can't stress enough, you will need to be safe on installing these things. I don't want to hear anybody getting shocked or anything because they're not turning breakers off, or simply they can't turn breakers off to their entire panel. So please consult an electrician when you get these CT clamps installed. So other than that, the CT clamp installation is fairly simple. They just get clipped over the wire, so no wiring has to be removed. It's non-invasive. It doesn't actually cut into the wire itself. So you can see here I have mine installed on the side of the panel, and it's just installed in a little 3D printed case next to the panel itself, and it works great. So one thing I did want to mention for all you solar people out there, this is also a great solution if you can't easily with local control monitor your in and output of your solar power. I'll leave a link to the crowd supply information where he gives a lot more information on using this with solar and various other options. It's definitely got a cool little video and a great little read you can check out on the crowd supply link. And I'll leave that down below in the description of the video. So one last little bit on safety with the CT clamps. Once you have a load on those CT clamps, do not unplug them from the board, especially the ones without an internal burden resistor. That's the ones that's going to be an output with, say, 50 milliamp output and not the voltage output. So Open Energy Monitor has some very great documentation and safety tips concerning all the CT clamps. I would highly recommend before you start digging around in things with the CT clamps, definitely give that a read in the description of the video below concerning the safety of the CT clamps. So if you don't read any of it, definitely read the sentence we highlighted here. If you unplug it, this will produce a highly and potential dangerous voltage across the secondary, meaning that tip could become hot even though you've just simply unplugged it from the power monitoring board itself and you have all the power going through your home, which is passing through that CT clamp. So all in all, it is pretty safe, but just you need to know what you're dealing with when you're doing energy monitoring of the whole home. So enough about all that. Let's go check out the board, and we're going to show you how to put it in ESPHome and get it calibrated. So there are two versions of this board. This is the 6-channel version. They also have a 2-channel version. At the time of the recording of this video, I don't know if you can order a mixed type of board where this one has two 3.5 millimeters and then it has the quick connect screw terminals. Now what I mean by that is the split core transformers. I know you've seen these before if you've watched my dryer videos, where we built one to see the dryer if it's going to be on or off to do our voice notifications in Home Assistant. This board actually uses 6 of these split core transformers of various sizes and types, and you can mix them as you can change the calibrations in ESPHome. Now typically when you do order these, they come with a 3.5 millimeter plug, and you can simply plug these in, and I would, when you plug these in, hold a little pressure, that way you're not forcing all the pressure on the board, you won't rip the plug off. You simply plug them in and call it a day. Now if you've cut the plugs off in various projects, such as I've done in one revision, you only have your red and white wires, and then you'll need to use the screw terminal type. Now, as I mentioned, you can use various different types of split core transformers. As you can see here, I have 100 amp, 50 milliamp, a 50 amp 1 volt, and a 30 amp 1 volt. There's 6 traces for the split core transformers, and you will need to sever the ones that are using a voltage output, since that takes out the burden resistor that's built into the board. Now, I have found this one, the 100 amp version. You can find them at great prices, sometimes even cheaper than the lesser models, the 50 amps and the 30 amps. They make several different sizes and also made by different manufacturers. But due to the chip on this board being so accurate, you can measure even a simple LED light bulb with the 100 amp SCT without an issue. So if I was doing this all over again, I would just get these 100 amps and use these in all my various circuits. Now, one thing to note, the power input is not DC voltage. Do not power this with your standard power brick that is typically DC volts of 9 to 12 volts. If you'll notice on the board, it says 9 to 12 volts voltage AC only. And this is what I'm using to power this board as a 9 volt AC 1500 milliamp power transformer. And of course, we will leave the links to all the various parts and pieces of this integration in the description of the video. And do always check the description of the video. If there's ever any updates, we will update the description of the video with any changes as needed. So for the board, you will need an ESP32, and do make sure the ESP32 has ground and then 3.3 volts at the top near the antenna like this one. There are some models of the ESP32 breakout boards that do not have this same pin out. And you'll put the pins all the way to the top, leaving the bottom pins not used. And there, in my model, there is a little filler down here to prevent you from putting the ESP32 too far down. And just simply push it down, and that's it. And the board is pretty much built, and you connect your split core transformers. Now, one thing to note, when you are doing the initial programming of this with ESPHome, you'll want to split the board from the chip, program the chip via USB before you put it on the board. That initial programming will be done through the USB cable, and then once you're done it once, we can actually program everything using OTA in ESPHome using the GUI. So we're not going to go too in-depth on the 2-channel board, but this showing next to the Sonoff Basic, which I guess that's good for something in this video, is showing a size relation to the actual 2-channel monitoring board. It's super small, as you can see, even by Wemo's D1 Mini. It's pretty comparative in size. It's super small, and you can just connect the little jumper pins over to an ESP32 using some DuPont jumper wires. Of course, since it is just the 2-channel power monitoring board, you're going to get the spots for the 2 CT clamps, and it only has the 1 power monitoring chip on it. Pretty simple board, very reliable. I have used this exact board for months, and I only took it out to replace it with the 6-channel board. So if you only need 2 circuits, you don't need all 6, definitely check this board out. It's a pretty cool solution. So currently, as a recording of this video, and it should change fairly soon, is the sensor required for ESPHome is currently only available in the development version of ESPHome. So you will need to install the development version of ESPHome. Now, once that is tested enough, it will make it into the next revision of ESPHome for the standard version. So we'll go ahead and install the development version. If you are using something else like Unraid or roll your own type Docker setups, you will need to change your Docker tag. Instead of being with the latest, it'll be dev instead. If you're already familiar with ESPHome, you can probably skip through some of this, as I'll leave the link to the entire YAML file that I use in a GitHub link, including some of the calibrations I did for my SCTs. But we'll go ahead and do a initial node, and the name of the node, we'll do it DigiEnergy, and remember, these have to be lowercase and must not contain any spaces. And we'll call it _6C for 6-channel. Hit continue. It is an ESP32, so we need to select ESP32, and we'll just use the node MCU 32. Hit continue. Wi-Fi SSID, you'll go ahead and put that in. We will utilize our secrets YAML file in the one we do post to GitHub. We won't be putting an access password. Hit continue. You can if you want, and we'll hit submit. At this point, if you do have it connected directly to your Pi or server or whatnot, you can go ahead and flash it straight using the USB port. Now, I don't have it connected to my server, so I'm going to go ahead and do a compile and download it and then flash it over USB using the Esp Home Flasher. And also, since I do use static IPs with my various VLANs, I'm going to go ahead and edit the file and put it in my information, but you may not have to do that for your specific network. So paste it on my Wi-Fi information. I'm not going to be using the captive portal. I don't need that on this particular device since it is an easy to flash device using USB. We'll leave the logger in. If you are using the API, you can go ahead and leave the API in. I'm using MQTT with this one. Paste in that. We'll leave the OTA in. We'll also throw in our web server. And that's it. It should give us a booting, kind of a rolling chassis per se of the ESP32. That way we can put that on the board and then go ahead and power it with the 6-channel or the 2-channel board. And then we can flash all of our different sensor updates and calibrations straight from the board without having to use USB. If you are using through USB right now, you could hit the upload and just go ahead and flash it. We'll need to go ahead, in my case, and do a compile, and then we'll download the binary. Once the compile is finished, we'll hit download binary. Next, I'm going to grab the Esp Home Flasher. So go to Esp Home Flasher. Again, we will leave the links to all of this for you can quickly just jump to it instead of having to dig through any documentation. Releases, and we'll download the one for Windows. While that's downloading, we'll go ahead and connect our USB cable to the Node MCU and plug it into the USB port on your computer you're flashing from. So go ahead and open up the Esp Home Flasher and select the COM port of your Node MCU, and then browse to the bin file you just downloaded from the compile. There's our DigiEnergy 6-channel bin file, and then we'll hit Flash ESP. Let it go ahead and flash, and then it will actually open up the serial port and show it connecting to your Wi-Fi. So we can see it flash, it actually rebooted, and it is connecting to my Wi-Fi, along with connecting to MQTT or the API, etc. Now, we don't have the power monitoring board sensor set up, but we just wanted to get this little initial one going. That way we can put it on the board itself. You'll also notice in the dashboard, you should get the green online light, as well as being able to view any various logs. Now, there's nothing going on currently right now, as it's not moving or changing sensors. You may not see anything in the logs. So we'll go ahead and disconnect the Node MCU, and we will place it on the power monitoring board. Just make sure and take note of the correct orientation on the power monitoring board before you do so. So we place the ESP32 on the power monitoring board. We'll go ahead and power it up. You'll notice the green light turns on, and depending on your ESP32, you may get a onboard LED that will blink with the different statuses of Esp Home. You'll also notice we did go back online. That way we can just go ahead and make all of our edits straight in the GUI and send them straight over using OTA. Next, we need to copy in some sensor information, and you can get that from my sample GitHub file, which I'll leave in the description. You'll need to copy in the SPI because this uses SPI to communicate with the 2 chips or the single chip as well for the 2-channel. The pin number should be the same based on your ESP32 should match up with the pins along the side, which is marked on the board. And also I'll use some substitutions up top so we don't have to keep typing the same name over and over. Just call this one Digi6C, and we'll use an update time of 10 seconds. Now in this example, this will be for the 6-channel board, so if you do have the 2-channel board, you can use the same example that we have in the GitHub. It will be set up just for 2 channels, and it's just a simplified version since it just has 1 power monitoring chip on the board instead of the 2 like this board has. So once we paste that information in, you'll notice I do have a Wi-Fi signal that updates every 60 seconds. That's optional if you don't want to put that in yours. You can see the CS pin, which is part of SPI bus, is on pin 5 for the first chip. You'll notice if you scroll down, you're going to get CS pin 4, which is going to be for the second chip. You notice under the platform, it's ATM90E32. That is the chip that does the power monitoring. You can come in here and tweak this, and I'm sure there'll be many other people that have found various other ways to change the sensors. If you do that, please do share it back with us, and that way we can update the GitHub or and the description of the video to make it better for others in the future. So for the gain voltage, this is set for the 9-volt power supply. If you are using a different power supply, such as a 12-volt AC power supply, you will need to change the gain voltage and also to tweak it based on the voltage in your area. Now the gain CT is going to be specific for each CT clamp. You may find between different manufacturers CT clamps or even the same manufacturer, just due to differences in the way they made it or whatnot, you may have to change some of these numbers to get them exactly right. Now how do you know what is right? If you have a calibrated power monitoring plug, such as a Sonoff S31, a Sonoff PAL, etc., you could use that and say use it with a 60-watt old school light bulb or something else, some type of load that is a constant draw that you can just turn it on and it's not going to be something, say, like a soldering iron that turns on and off. You'll drive yourself crazy trying to calibrate this with a soldering iron or something else that's cycling on and off. Or if you want to make it really easy, you can go to your local hardware store or you can order them online. It's a clamp meter that you can just connect over the wire. It's simple. You just push the little button, clamp it over the wire, and clip it down, and it will show the amperage output on the LCD screen. They're very simple to use, it's very safe to use. Many of them also include voltmeters and many other testing. And just check with your local hardware store and see if you can get one of these or on Amazon or something like that. So I've already calibrated these, but I wanted to show you the process for calibrating these and how simple it is. So instead of getting rid of this value, we'll go ahead and copy and paste it and we'll comment it out. We'll go ahead and start this value at 10,000. We'll go ahead and hit save. We can hit close, and just to make sure, since we did paste in a lot of different things, we'll go ahead and hit validate. It is valid. We can go ahead and upload it onto the power monitoring board. Again, since we're using OTA, you don't have to connect it back up, don't have to disconnect it, because you don't want to connect USB to the power monitoring board at the same time that it is powered from the board itself. So once it flashes and reboots, you should notice now that you start to get the polling every 10 seconds of the two power monitoring chips. You'll see the voltage, you'll see the amps, the frequency, etc. And now we'll go ahead and we'll want to tweak the amperage for the one clamp we put on there. And you'll repeat this process for any type of clamps you do on these 6 channels of this board. So at this point, you could go in and do the integration part if you're using the API, or just go ahead with MQTT in the unused entities and find your sensors that are now posted from this chip. So there we have it. You can see inside of our unused entities, we do have the 6 CT amps along with the frequency for each side, each chip, along with the voltage. So now we need to do a calibration to get our clamp on par. Now with CT clamps, you can't just place the entire clamp over, say, an extension cord like this. You won't get a valid reading, or you may not even get a reading at all. What you need to do is just be over one leg. You can't be over the neutral and the load of the wire. So this particular extension cord, it does have 3 conductors and you can split them. So whatever you can come up with to where you can just get over one leg of your cord for your calibration, and you could just put the clamp over one leg of the extension cord like I've done here. So you can see it's just over one leg of the extension cord and the ground and the neutral is on the other side. Now do note, if you are using the internal wattage of the power monitoring board, the orientation of forward or backwards will be based on the phase that you're connected to for the direction. Now if you do end up with some negative wattage, you can actually just go in and put a filter and multiply that by -1 in ESPHome to flip that wattage back around the other way. Now in the 6th channel, we are going to be using just the voltage and the amperage to calculate our wattage. Now for this initial test, we will be using just a standard 60-watt light bulb, which of course in the US, given around 120 volts, 60 watts, that's going to do about half an amp of current draw. As you can see on the amp meter, we are pulling 0.49 amps, which is pretty close to half an amp. As it does jump around a little bit here and there, we're going to try to get this at half an amp with the calibration of the clamp. Now you can see on ESPHome, behind it, it is showing 0.32 amps. So we'll need to change that calibration to get that in line to being half an amp. So really simple, we'll go back to ESPHome, we'll edit the sketch, and we'll go down to the first clamp. And the gain is set at 10,000 again. So we'll go ahead and see where we're at. Let's go ahead and do it to 13,000, and we'll hit save, and we'll hit upload. The compile time should be much shorter because it doesn't have to compile all the libraries just to change that one calibration. Now, if you don't want to go straight into Home Assistant to look for your values, you can, since we did include the web server on the ESP32, you should get a blue little square link that will jump you straight to the web server and show you the different states of the sensors. So we got 0.42. It's pretty close. As you can see, you just keep playing with this number and get it close to what you think is a good value for your clamp. Now, of course, the bigger load you put on it, the more accurate it's going to be. So for instance, if you have, say, a 50 amp clamp, if there's a way where you can put, say, a 10 or 15 amp load on it, a constant load, you could get a much more precise calibration. So we'll change this to 14,500 and we'll go ahead and upload it. So you'll see now that puts us 0.47, pretty close. Now I did calibrate some of these clamps using about a 10 to 11 amp load, and it got me a little more precision like I spoke of, even with the light bulb. So we'll go ahead and set this one to that 15,420, and we'll save it and we'll do an upload. And once we did put that number in there, you can see that puts us right at our 0.50 amp for this light bulb. So pretty simple to do the calibrations. It just takes some jumping around, some guessing on some numbers, and just how fine-tuned do you want that for your particular device you're trying to monitor. So we did speak about before, we are using some calculations to calculate the watts on the 6-channel board. So what we can do is we just copy and paste in a template sensor, which will take the CT1 amps and multiply it by the volts. We don't need any decimal places. Now you can, if you want decimal places on your wattage, you can add them in there, as well as changing the icon, the name, etc. But if you want, just copy it in like I did here. And also, if you're wanting to add two sensors together, say for instance, one example, which I'm going to do, is say CT clamp 1 and 2 will be your mains power, because I use a split phase here in the US, and I want to see at a moment's glance just what the total amperage I'm using in the home. But then I don't want to see CT clamp 3, 4, 5, and 6 in that same total, because those will be sub circuits that I have that will be already in that total. So what I'll do is just do another template sensor and add the amperage of CT1 and CT2 together, which in ESPHome makes it really flexible to do exactly what you want in the YAML file. So upload that little change and we should get that new template sensor with the wattage based off of the voltage and the amperage. Now refresh the web server, you can see it has the CT1 watts of 61 watts based off of that template sensor. So pretty simple stuff. Now in the example, we will show also a kilowatt-hour sensor, and you can just copy and paste that in and it will calculate your kilowatt hours for the day, which is pretty cool. So that's it for calibrating the power monitoring board. If you got any questions, definitely check out the video description, and you can hit the link on the Discord server and you can jump in and someone can help you if you get stuck on trying to calibrate something, and I'm always in there as well. So there you have it. You can monitor your entire power home usage, your solar usage, various circuits, etc. Really whatever you want to come up with. And you can have some very accurate power monitoring in your home. We use it to monitor various circuits in the home and feed our graphs of Grafana, which give us a lot of information right at our fingertips of all the various circuits. I have one lighting circuit that's holding 0.29 amps and steady. And if I go ahead and turn this dimmer on, and you'll notice the percentage I'm turning the dimmer on is not that much, and it's just 3 simple LED bulbs over the table. Now you'll notice we went up 1/10 of an amp on that lighting circuit. We'll jump to halfway and we jump up to 0.36. We'll go to full brightness and we jump up to 0.44. And you'll notice it's holding steady as well. It's not jumping around, there's no noise, and we're back down to almost our original level of 0.29, which is where we started at. What other power monitoring can you do with that with a 100 amp clamp measuring that power circuit? That's simply amazing to me what that chip does with those CT clamps. So don't be scared to check out this project. I know we had to talk about a little safety issue, but we just don't want anybody getting hurt. Definitely a very cool project. Check out all the various links in the description of the video. It's a lot to take in at first, but it's actually a very simple and very powerful project you can do in your home. And it also does with ESPHome, which integrates directly into Home Assistant. So I appreciate you watching this one. Definitely check out anything we have in the description of the video. We will put any updates in there as things progress. If you got any questions, definitely give us a comment down below. We'll get it answered. Give us a thumbs up if you like this video. And also, check us out on Discord chat if you got anything else further you'd like to talk about. Thanks, and y'all take care.